Good afternoon, everyone. Thank you very much for joining us today. I'm Carolina Becerra, bilingual facilitator at CEIBA. Welcome to our CEIBA Dev Fest 2024. We are thrilled to kick off this event that has been connecting LATAM with technology and innovation for the past 12 years. Prior to 2020, this event was more like a private gathering for our CEIBA team members. However, in response to the pandemic, we transitioned the event to a virtual format, making it accessible to the public. And this year, we are proud to present a hybrid format broadcasting from our office in Medellin, with the presence of our collaborators, as well as those joining us remotely from across Colombia and other countries. We're showcasing the power of remote work and fostering a truly global community. As a leading technology company, CEIBA Software is dedicated to delivering innovative solutions that meet the unique needs of our clients. CEIBA Software is your partner in transformation. We offer a wide range of technology, including customer software development, user-centered design, digital transformation, DevOps, intelligent process automation, artificial intelligence, Salesforce, and of course, agile methodologies. And just a friendly reminder, note that all our talks are being recorded and will be available on our YouTube channel, CEIBA Software. Plus, this year, you can find them on 2 channels. Channel number 1, Technology and Innovation. Channel number 2, Experience and Evolution. And we're halfway there. We've already enjoyed 8 talks, and there are 7 more to come. You can all check the full schedule at ceiba.com/CEIBA-DevFest. You can also have a look at the description on this channel for updated details. Additionally, we would like to give you some tips for getting the most out of this event. Early connection is recommended. Kindly join the talks a few minutes prior to the start time to make sure you're all set. Double check your internet connection. A strong, stable connection is essential for a smooth experience. Set up your workspace. Find a comfortable location where you can focus on actively participate. Wear headphones for an optimal audio experience. Enjoy the conversation. You can use the live chat to ask questions or share your thoughts during or after the talks. Your input makes the experience even better for everyone. Navigate both channels, check out the schedule to pick your favorite talks, and switch between channels based on your preferences. ceiba.com.co/CEIBA-DevFest. We want you to get social, right? So join the conversation using the hashtag CEIBA-DevFest. We invite you to tag at CEIBA, post some photos, use the hashtag CEIBA-DevFest so we can see where you're connecting from. Without any further ado, prepare to be inspired. Our next speaker will discuss 3 effective rules for successfully using signals in Angular. It is undisputed that signals will shape the future of Angular. At first glance, signals may seem very easy to use, like variables with getters and setters. However, if you begin using them this way, you will encounter several pitfalls. To avoid such situations, we discuss 3 effective rules of thumb that help you leverage the benefits of signals and reactivate systems in general, making your source code more maintainable. You'll be surprised by the difference these 3 rules can make. Now, let's welcome Manfred Steyer. He's a training consultant and programming architect with a focus on Angular. He's a Google developer expert who writes for O'Reilly, the German Java magazine, and for Windows developers. He regularly speaks at conferences too. Mr. Steyer, it's a pleasure to have you here, and welcome.
Yeah, hi, and thanks for having me. So you You should see now my screen. And if you green lights me, I'm ready to go.
Okay, well, we cannot see your presentation yet, can we?
Okay, let me double check.
Thank you. There
Now
you
they
go.
can
Now
see it.
you're ready to go. Okay, well, Mr. Steyer, this space is all yours, and we really appreciate you. And thank you for joining us today.
Awesome, awesome. Yeah, so by the way, do you see my screen now? Yeah, now you should see it. Now it looks good. Great. Yeah, so once again, thanks for having me. It's a pleasure to be with you this afternoon. For you, it's the afternoon, I guess. For me, it's the evening. And I want to talk a bit about signals, but also about another topic, namely my home country, Austria. Perhaps you know a bit about Austria. It is known for its countryside. We have a lot of nature. We have the mountains, as you see here. A lot of people do skiing. But there is another thing about Austria most people don't know. But it's all the time on our minds. We speak not about it, but it's all the time on our minds. It is Sacher cake. Perhaps you know about Sacher cake. It's associated with Austria, to be more precise, with our capital, Vienna, where Hotel Sacher invented it several, I think, decades or even centuries ago. And this is what this presentation is about. It's about Austrian desserts, which is quite a serious topic, if you ask me. So first and foremost, this all is about Austrian desserts, but I will also talk about other stuff in the area of Angola, which is computed signals or effects for signals. Also, we will talk about the RxJS interop and stores. And from all those topics, we will distill out 3 rules of thumb that really help you to write sustainable, stable applications with Angular and signals. And we will distill out 3 hints that also help you. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies with training workshops, but also with consulting and reviews. Meanwhile, we do this remotely and on site. Besides this, I'm also connected to the Angular community. I live in Austria, where we have, Sacher cake. I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the globe. Okay, cool. So let's get started with the most important topic, namely Austrian desserts. Austrian desserts is what my example application of today is about. So let's open it. So here you see several desserts Austria is known for. There is Sacher cake, there is Apfelstrudel, our kind of apple pie, if you want to call it that way. And there is Austrian pancakes. We call it Palatschinken. So perhaps you have a similar name for it because the term Palatschinken comes from the Latin term placenta and basically means cake. And yeah, this is the term we are using for this kind of pancakes. And as you see here, you can rate all those desserts in this example application. However, when it comes to ice cream pancakes, Eispalatschinken, ice cream pancakes, then 5 stars out of 5 stars is not enough. And that's why I have implemented a cheat mode here. Just double click the 5th star and you can give up to 500 stars, which is not too little for ice cream pancakes, trust me. Yeah, so we can also search for the original name like Palatschinken or by the English name, which is in this case something with cake. And there you see we get a filtered result. Also, we can load expert ratings. In this case, you get my rating so that you precisely know what to go for when visiting Austria next time. Okay, cool. So this is my example application, and using this application, I will show you all the things signals. Okay, let's go on. So before we start, let's also talk a bit about signals. To get everyone in the boat, I have prepared 4 slides about signals in general. So signals are this new reactive primitive in Angular, a new reactive building block that is basically wrapping a value, and a consumer can read the value, a consumer can update the value. And this is now important: when the value was updated, a consumer can get notified. And this allows us to stay up to date, especially it allows Angular and its data binding to stay up to date and to update this or that portion of your application. And this is all about change detection. It's all about finding out then that when this signal here is changing, we just need to update this very component, perhaps here in the bottom right corner. How does a component with signals look like? Well, you just need to wrap everything you want to data bind in a signal. For this, you have this helper function signal. You see it here. And then you can use a setter to set a value in the signal, or you can use the getter to read the current value. The getter itself, you see it here, is just a signal name with full parentheses. So you don't have to write .get, you just use the name with full parentheses, and this is your getter. However, here in this case, more happens than you will very likely think, because if you use the getter in a so-called reactive context, and the template is such a reactive context, then the context will subscribe to the signal. It will track the signal, which means it will be notified when the signal is changing. So in this very case, the template will always subscribe to the SQL. And so the signal will tell the template, hey, I have been changed. And so the template, or to be more precise, Angular knows, well, now I need to update this very part of our screen of our application. That means subscribing, tracking happens automatically. And the same holds true for unsubscribing. You never need to unsubscribe. It's not even possible. This is automatically done for you by Angular and its signal implementation. There is another thing that is very nice when it comes to signals, namely computed signal. So what you see here is another signal that is computed out of existing signals of my signal from and to. And the result of this is my flight route. It's just a string with from to. And the best thing about this is that every time one of the used signals in there are changing, everything is recomputed for you. And so you are always up to date, which is quite nice. Another aspect of signals is similar to computed, it's effects. An effect looks like computed, however, it's not returning a value, it's triggering a side effect. A side effect like printing something out to the console. In this case, from my airport of departure is printed out to the console, and every time from is changing, this effect will rerun. This helps you to keep in sync with your data. Okay, this is quite nice. And this was to get everyone into the boat. But now let's talk about signals from an architectural perspective so that we can distill out our rules of thumb. The first perspective I brought for you is computed signals. Let's talk a bit more about them. For this, let's jump into my example application. By the way, you always have here the name of my branches. That means if you want to check out my source code afterwards, just look into those branches to see the source code from this or that part of the presentation. Okay, so let's move into our source code. What we see here is several signals. Everything I want to data bind is a signal, like the original name, the English name, there is a loading flag, and there is a signal for my deserts, for my results. And as you see here, when I want to search for deserts, I just put the current values into an object, my search criteria, like an original name and the English name. I'm setting my loading indicator, and then I'm I'm triggering this find method. The find method gets the filter and it is using it to search for deserts, and when we have found some deserts, I'm putting them into my desert signal. So I think this was quite straightforward so far. However, when it comes to loading the ratings, it's a bit more complicated. Because here you see I'm loading the expert ratings, and then I need to combine the ratings with my deserts, because I want to see the ratings side by side with the deserts. If you look here into my application, you see the ratings are really displayed alongside my deserts. So I need to combine both of them. I need to join them, if you want to put it that way. And after that, I got rated deserts, and I'm writing back those rated deserts into my desert signal. And honestly, this is really a mess. This is really a mess, because if I implement an application that way, I need to remember time and again to update my deserts with the ratings. I need to remember to do this after I've loaded deserts, after I've updated deserts, after I've loaded ratings, after I've updated ratings. It's really a mess, because if I forget about this, my application will be out of sync. And this is where computed signals really help. For this, let me switch into the mentioned branch 02A something. 02A something. Here we go. So one thing that is different now is, now deserts are a signal, but also the loaded ratings are a signal. And look what's happening here. Here I'm computing my rated deserts. I'm just calling the helper function doRated, that is joining both sides, and I'm passing in my desert signal and my rating signal. And as mentioned before, a computed signal is always kept up to date. Always you read it, you get the current value. It knows when to recompute. And so I don't need to think any further how and when to join both data sets together. It will just work, it will just happen when either this or that guy is changing. So this means that a computed signal is really a cool thing from an architectural perspective for things like a view model. If you need to represent your state in your application for a given view, like deserts and ratings together, then this is what you very likely want to go with. Okay, so this makes my application a bit more streamlined, and this brings me to my first architectural rule: synchronously derive state wherever possible, because it gives you state that is up to date. You can end up with inconsistencies and redundancies. And this is more in the sense of functional and reactive programming. If we talk about functional and or reactive programming, then usually we avoid writing state. Because every time we need to write state, we can end up with inconsistencies and other issues. So it's more usual to derive your state in such a functional way. That means your component will end up as a formula, just a formula describing how the inputs will be projected to the outputs you want to go with. Now let's talk about a bit more complicated topic. Let's talk about effects. And for this, I want to give you a first point of information. Effects are mainly for rendering. For rendering out stuff to your application, you cannot render with data binding. Of course, in Angular and also in a lot of other frameworks, data binding is the preferred way of rendering stuff out. But sometimes data binding is not possible. Just think about displaying a message on the screen. Very often we have to call a method for this. Or perhaps you need to update a data source object. Also for this, we need to call a method. So effects are really mainly for this last mile, for displaying data in a way that is not possible with data binding. As we will see a bit later, there are also other use cases, but for the time being, let's stick with rendering. So let's move into the next example. It's this branch here, 04C. And here I have two ideal typical effects. The first effect here is writing out something to the console. Obviously, this does not work with data binding. And the second effect is displaying a toast message. So just a message that will pop up for some seconds. And it's always displayed when the amount of desserts is changing. It tells us, well, now we have XYZ desserts loaded. Let's see this in action. So first of all, let's search for some desserts like Palatschinken. And here we see 2 desserts loaded. And now let's go with cake. 3 desserts loaded, that's good. And now let's have a look to the console. Let me type stuff in, and you see also this effect works. Awesome. But there are several things in effects that you might not have expected. For instance, if you refactor this here into a function of its own, let's say we call this function, log stuff, then the effect will even run when original name or English name is changed. It will run even though it is used in the called method. And even if we put it into another method, the effect will run. So we don't see that the signal is used in here, even though the effect will track those 2 signals. We can prove this easily by looking at the console. And look here, everything is written out to the console. And if you think about this a bit, this really fits well to what I told you before about effects. They are mainly about rendering. I think if you would trigger business logic, this might be confusing, because now you would trigger business logic in situation you would not foresee because you don't see the signal in there. When it comes to rendering, however, then this is exactly what you want to have, because you render out stuff once, and every time this stuff is changing, you want to re-trigger rendering. You want to re-render your stuff. Makes a lot of sense. You need to re-render every time this or that here is changing. So this shows, and this also emphasizes, that effects are mainly there for rendering. There is another thing that might become as a surprise for you. So let's assume after some seconds, we are changing the original name. Let's say we are changing the original name to A, B, and C in a row. First of all, we have A, then we have B, and then we have C. And then assume we are doing the very same with the English name. X, Y, and Z. So it might come as a surprise now that we will only see the final result on the console, which is C and Z. A and B, X and Y is swallowed. It's not respected by the effect. We will see it here. only see and set. And one more time, this emphasizes what effects are meant for. They are meant for rendering. Usually when a lot of stuff is changing in a row several times, we don't want to render intermediate result. It would be quite an overhead to render out an A just to immediately replace it by a B and a C. This would not make sense. And so, yeah, this one more time shows effects are mainly for rendering. At least rendering is one of the main use cases there. This brings me to my second architectural rule, which is avoid propagating state and signal writes using effects. Because you have this strange behavior or this behavior that might be strange if you want to trigger a service or some business logic, then a signal is changing. However, if I say avoid propagating state, then the next question is how can we react upon changing state? Because after all, we have a reactive system, and sometimes we need to react on a change in a signal using a method call. So how can we do it? Well, as mentioned before, effects are problematic here. What you want to do is something like this. You have an event that is changing a signal, and because there is a signal change, you want to run a business logic. Effects are problematic here because of the so-called glitch-free property, which is the fancy technical term for what you have seen before. You just see the final result. If you change something to A, B, and C, you only see C. If you change something to X, Y, Z, you only see Z. Intermediate values might get lost. This is one of the issues you might have here. You might trigger your business logic not often enough. This might also lead to subtle timing issues, because in order to make glitch-free work, the effect is postponed a bit. And this means that your data will be updated a bit later, some seconds later, which might lead to timing issues. Also, auto-tracking. Tracking everything within the called methods and within the methods called by the called methods might be an issue here when triggering a business logic, because you cannot tell at first glance when the business logic is triggered. And you might end up with cycles and change cascades, because if one change leads to another change, this change can lead to a further change, and that change can lead to the first change, which is not just a change cascade, but also a cycle, something very likely you want to prevent. And last but not least, an effect is always the end of the reactive chain. It's always the end. However, if you want to trigger a service, a business logic, then this triggering happens somewhere in the middle. One more reason why the effect is not the best choice here. So if an effect is problematic here, what can you do? Well, oh, by the way, let me tell you another thing why the effect is problematic here. The effect is not helping you if you have overlapping requests. So let's say you are searching for pancakes, and before you have the result for pancakes, you start searching for Sacher cake. And before you have the result for Sacher cake, you start searching for ice cream pancakes. Usually the user would expect to only see the results for ice cream pancakes. However, as the effect does not help you with such a situation, the user will see all the free results. For a little tiny time period, the result for pancakes will show up. And then, for a very little tiny time period again, the result for Sacher cake will blink up. And then you will see the result for ice cream pancake, which is really a weird user experience, I guess, if just little tiny results blink up, show up for just a tiny amount of time. This will be the default behavior of effects, and usually you want to avoid behavior like this. To deal with such a behavior, you might call it a race condition or overlapping requests, you can go with RxJS. RxJS is really good when it comes to prevent such situations. There are operators like SwitchMap that, for instance, only go with the last result. So if you cannot use effects for all of this, what shall we use? Well, one possibility is to just use the event behind a signal change. Usually a signal is not changing by itself. It needs some event that is updating the signal, a click and a mouse move event, a timeout event, a data event. And that means you can use the very same event not only to update the signal, but also to trigger your business logic. This is one possibility. Think about a cascading drop-down field. In this case, you go just with the change or selected event to trigger the business logic, loading the data for the second drop-down field. Another possibility is to use RxJS. As mentioned before, RxJS is really great when it comes to dealing with overlapping requests, and you can combine it perfectly with signals. As we will see in some minutes, there are bridging functions like toObservable, converting a signal to an observable, and toSignal, converting an observer back to a signal. That means you can have best of both worlds, going with a lightweight approach like Sequence and going with a very powerful approach like RxJS. Another thing you could do is you could go with reactive helpers. Reactive helpers like we find in several helper libraries. For instance, the RxJS signal store has a method called RxMethod. It allows you to set up a method that is triggered every time a signal is changing. Or the open source package ngExtension is also bringing several reactive helper functions. You can bring your own helper functions, your own reactive helper functions. Today I will implement one for you, a very usual one. And you can use Angular itself. Angular itself will get reactive helpers with the next versions. Currently there are none. Perhaps you can see toObservable and toSignals as such reactive helpers, but there will be even more in the future. Let me show you a demonstration for this. For this, let's move to my 08B branch. So what we have here is similar to what we had before, but now we have this detail button. And when I click it, I see this beautiful detail view that also allows me to scroll through all my records with stepping one step forward or one step backwards. That means every time I'm clicking those buttons, an ID is changing. And every time this ID is changing, I need to load the respective record. So let's have a look into the source code here. That's the wrong source code, detail component here. So what we see here is an ID, and this ID is an input. Actually, it's a bit more than an input. It's a so-called input signal. You see it here, input signal with blah, blah, blah. This is similar to what we did before with add input. But now input is not a decorator anymore. Now it's really a function you're calling here. Plus, it gives you a signal, a so-called input signal with the current value. And in my case, every time I'm changing the ID is written into the URL. There is a URL parameter with the ID, and the browser, no, not the browser, the router, the Angular router is taking this ID and putting it here. Meanwhile, we can configure the router to map routing parameters to inputs having the same name. So the routing parameter is called ID, and this input is called ID. To cut a long story short, this signal here is always reflecting the current ID I need to load. So what to do with this ID? Well, currently I'm using ng changes to react on new values I'm getting in. I'm reading the ID and I'm telling my store to load ID. And this is completely fine. Using ng changes is completely fine for now. Because eventually we will get a new type of component in Angular. The vision is that we will get eventually a so-called signal component. There is already an RFC for it. And such a signal component is only supporting signals, and it won't have ng changes. Instead, we can go with an effect. That means at first glance in future, we can use something like this here. This was the wrong key. We can use something like this here, an effect that is reading the ID and then loading. However, this exactly brings the issues we've discussed before. We can end up with race conditions. However, in my case, the store takes care of them. But besides this, we have also this auto-tracking behavior. So just imagine the load method is reading a loading flag in there. We don't see it here, it's read in the load method or the user ID. Then this effect will rerun every time the loading flag is changed and the user ID is changed. And this will cause a lot of confusion. This will be strange behavior if the effect will run every time that one of them is changing. We just want the effect to run when the ID itself is changing. So what can we do here? Well, we can go with a reactive helper, and here my store is using such a reactive helper. It comes with a reactive method. I calls this reactive method rxload, and as it is an reactive method, I can connect a signal to it. And this means this method will run every time this ID is changing. You can also pass in an observable. Then the observable will be connected to it, and that means the method will rerun every time the observable is changing. So let's have a look into this rxload method. You see here I have my store. I'm setting up in my store several methods. For this, it comes with the helper function with methods. And in there, I'm defining rxload, which is just another method. Usually, when defining a method, you directly implement it here. Here, instead, I'm assigning the result of rx method. Rx method is typed with number. That means I get a method that takes a number or a signal of number or an observable of number. And every time this number is changing, this number goes through this very reactive pipe here. And now we are in the world of RxJS, which means we can use all the power of RxJS, like using switch map, which is preventing race conditions, for instance.
I'm so sorry, Manfred. Hello. Well, I'm so sorry for interrupting you, but we are running a little bit out of time, and we're 10 minutes left, right?
Okay, so just give me some minutes to finish up, and then that's it.
For sure, thank you.
Okay, so thanks for the pointer. Yeah. So this allows us to connect a signal to our store. It's just one of the helper functions we can go with. And besides this, of course, you can implement your own helper functions or also use other libraries. Okay, cool. So let me show you a last thing because I promised you 3 rules. The last thing I want to show you is about stores. And perhaps you're saying now, well, we are talking about signals here. Why does he talk about stores? Well, the thing is, if you ask me, the store itself is the missing link when it comes to signals. Why is that? Well, the thing is, if you have a reactive system, regardless if you use signals or not, you easily end up with a situation where one change is triggering another change, and this might trigger a further change, which might trigger the first change. And this is something you cannot control anymore. It's a source code that is very hard to maintain. So look here, this is what the source code would look like. It would look like the Incredible Machine. Perhaps you know this old computer game where the goal was to use physics to trigger side effects that are triggering side effects. And obviously, this is a nice game, but if your application looks like this, you really have an issue. And one way to prevent this is using a store. A lightweight store like a Signal store or a more heavyweight Redux-based store like the NGRX Classic store. When you go with a store, you are triggering something in the store. The store will take care of an action in a synchronous or in an asynchronous way. And when the store is done, it will put the result into a signal. And now via this signal, the new result, the new value can flow down to your components template. And when doing this, one more time, we can go with computer to project our values to values we want to display to our view models. This really helps you to manage your data flow. Some people call this the unidirectional data flow. You always go into one direction. Every time you have an event, you are triggering something here, something happens up there, and then the data is going down and we are done. This is really easy to reason about. This is really easy to manage, just going one cycle per event. Plus, another interesting thing is this here shows exactly the main use case for signals in the current versions of Angular. Very likely the use case will expand, but currently signals are mainly for transporting data into your component, transporting data into your component's view. More or less the right side. Everything else currently needs to be offloaded to the store or to other mechanisms. Okay, cool. So let me skip this demonstration. You have already seen the store before, and you find it in the source code I'm sharing with you afterwards. This brings me to my third architectural rule, which is stores make your reactive flow more manageable. If you like this presentation, you will also like my free ebook. It's meanwhile in the 6th edition. We have 20 chapters. You can download it for free here. And by the way, we are doing a workshop at the end of the month, at the end of October, with all those topics and even more topics. Please find all the information there. It's online and fully interactive. Okay, so let me come to the conclusion. We have seen 3 rules. The first rule is synchronously derive state where possible. For this, we are going with computed. The second rule is avoid propagating state with signals and effects. Effects are mainly for rendering, not for triggering business logic. And a third rule is use a store to streamline your reactive data flow to make it more manageable. And last but not least, there is one more thing I want you to remember, namely, it's actually a very important thing, namely, if you ever come to Austria, try out ice cream pancakes. It's the best dessert, 500 stars out of 5 stars. When it comes to this kind of desert, mathematics does not matter anymore. And that's it. You find my contact data here. Feel free to follow me on Twitter X to stay in contact. And please find my slides and examples on my blog. So thanks for having me.
Manfred, we cannot thank you enough for being here, and most of all, we really appreciate you sharing your expertise with us. Now, it's time to answer the questions posted in the chat. So please welcome Sebastian Reis, our technical coach from SEIBA, who will be supporting us in this section.
Awesome.
Thank you. Thank you. Thank you for the introduction and for the presentation, Manfred. That was a very awesome presentation here. Basically, we have some questions about your presentation. Right now, I was thinking about this new change that has been introduced in Angular recently. I'm sorry, we're having some feedback. Can we silence the? Basically,
Yeah, I think we need to mute Carolina.
Yeah, sorry.
Yeah.
Okay, that's all. We have a question here in the chat. Basically, Jose Fernandez is asking us, is there a plan to replace zones with signals? Which one has better performance or which has lower overheat?
Is it about zones, Zone.js?
You can hear you can read the question during the chat.
Oh, yeah. So I did not hear the second word. Is it to
Zones.
replace zones? Yeah.
Yeah.
So signals are one aspect of going zoneless. In the current version of Angular, we have now Angular 18, there is already an experimental zoneless mode. And if you go with signals, then you are safe with it. Then everything works without zone. Then you can throw out Zone.js of your application and your bundles will be a bit thinner. Plus, there is less magic in there because Zone.js comes with so much magic. However, currently, you don't necessarily need signals for going zoneless. It's the easiest way to go zoneless, but if you have observables and immutables, you can also go zoneless. But it's easier with signals, and eventually when we go with signal components, this new kind of components, then this new kind of component will guide us towards signals, and so it will not be possible to do anything wrong. Hopefully, that's the plan. And when just using them in the way they are intended to be used, we will have a good performance and zoneless will work.
Okay, thank you. So, do you think this will be better for projects that are beginning from the beginning? I mean, would you recommend to use zones or use signals to start with a new project?
Yeah, so if you start with a new project now, I would really go with signals because signals are the future of Angular. Everything will be adopted to signals eventually. The change detection, we will get signal components. The router API will be updated for signals. The form API will be updated for signals. We will get a lot of helper functions, perhaps not a lot, but a good amount of helper functions that help you with signals. And so you don't need to immediately start with RxJS anymore. So if you start with a new application, I would go with signals. If you have an existing application, I would at least think about writing new stuff with signals. You can keep everything else as is because Angular is fully backwards compatible in that sense.
Okay, that's great. That's great. And considering that in mind, this represents a change of the paradigm in the usual way that we used to use Angular. Do you think this has a very high curve of experience? I mean, how long will it take a development team to engage with this new way of thinking?
Well, at first glance, it's quite easy. We just have getter and setters. But as we have seen in the presentation, you also need to adjust your thinking about. You don't have to think in terms of setting this or reading this. It's more about thinking in terms of a data flow. So what can we do so that the data flows from A to B and so that it is transformed on the way? It's similar than with our XGS. If you love our XGS, you already have this thinking. If you don't have this thinking, then you need to adapt to it. So it's a bit of change in paradigm. So yeah, try it out and give yourself a bit of time.
That will impact also the designing time in the project. I mean, the designing this kind of application should be done in a different way.
Yeah, it's another way to think about your application, totally. It's more about to thinking about application as a formula that is projecting the input to the desired output. It's less about do this and then do that and then do that.
Yeah, yeah, that's true. There's another more technical question here, also made by Jose Fernandez. I also had this question too. Should we place effects only in the constructor, so can we use the constructors in another way, in another place in the code?
Yeah, usually you use effects in the constructor. A metaphor I like to use here is building a house. If you build a house, first of all, you install all your cables in the walls. And then you just plug in your devices. And defining your effects is a bit like installing the cables. It's installing a way to bring a signal from A to B. And then you just use it. And that's why a constructor is not a bad place. Technically, it needs to be the so-called injection context, which is the constructor, but also field initializer. And there are some other lesser known injection contexts like factories for services, for instance. And you can create your injection context by yourself if you inject the injector, but usually you don't need it. Usually you go with field initializers and with the and or with the constructor, and that's it.
Okay, okay, thank you. That was clear enough. I think we have already finished with the questions from Jose. We have another question here from Mauricio. He's asking us which state management libraries besides NGINX have implemented signals. What other flavors can we have to use signals in Angular?
Yeah. So we use NGINX a lot because it's the de facto standard in the Angular space for state management. I think on average, every fourth Angular developer is using NGINX. They have really a high amount of downloads. And within the NGINX family, there are meanwhile free stores that support signals. Currently, I really love the NGINX Signal Store because it's a lightweight store and it has been designed with signals in mind from the ground up. But also the component store and the traditional Redux-based store, meanwhile, also support signals. So if you already have one of them, perhaps the traditional Redux-based store, then you can get out signals of it. Just call select signal instead of select and Bob's your uncle. So this is really straightforward. But besides this, also other implementations move to signals like RX Angular, or I'm not completely sure, but I also think the NGXS people at least think about moving to signals. I have not looked it up if they already moved over to signals. But yeah, as mentioned, in general, I go with the NGINX family because it's the de facto standard in the Angular space.
Okay, Manfred, that was very clear. Nice from you. You're very kind. I think we have run out of time, so this was the last questions. Thank you for your talk, and go ahead, Carolina. Thank you.
Thank you.
Okay, well, we have come to an ending here. Thank you again, Manfred for joining us. Thank you, Sebas, for helping us out. And thank you, everyone who joined us at Ceiba Dev Fest in here. You can watch this talk again on our YouTube channel at Ceiba Software. And you can also find us on Facebook, LinkedIn, Instagram, and Twitter. Thank you very much, everyone.